What's up, you data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually step 4 of the path towards learning Python for beginners in data science and data analytics. And more specifically, in this video we are going to cover the joins and the unions. So we're going to start by explaining how they work in Excel. We're going to cover the left join, the inner join, the full join, the cross join, and the union. And then we are going to head over into Python, where we can write our code and practice with some real data. I will also post this notebook with the code, our raw data, which is these 4 Excel files, and this Excel file that explains the joins in my GitHub repo. I'm going to have the link in the video description so you can download them and practice as we go through this video. And before we start this tutorial, let me just say that if you're passionate with data science and data analytics, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting with the join. So we're going to start with the left join. So in a business scenario, we usually use joins when we want to bring data together. So let's say we have 2 different Excel files and we have a key, so a unique column that we can use in order to join these 2 tables together. In this example, just to help you understand this better, let's say that the operations department has this data, so date, day, visitors, and the revenue generated. And then the marketing department has another file that has data, marketing spend, and promotion. And you, the data analyst or the data scientist, want to bring these 2 files together in order to create one consolidated file, which is going to be this file over here, and run some analytics on it. Now, starting with the left join is when we want to keep everything from table A. So this is our table A, is like we copy this and paste it over here up until revenue is exactly the same, so nothing is going to change from table A. However, I want to create these 2 new columns, marketing spend and promo, in my output table that are going to come from table B. And the way the left join works is that we need to specify a key. In our case, the key is date because it exists on both tables, and it's what we are going to use to match these 2 tables together. So we start with the first line, which is the 1st of Feb 2023. We look into table B to see if we have the 1st of Feb 2023, which we don't. As you can see, we go from the 31st of Jan to the 2nd of Feb. So it doesn't exist in table B. However, because it's a left join, we're still going to keep the data, which is this data over here, so it's exactly the same, but we're going to have an empty space for marketing spend and promo because it doesn't exist in this table. Then we're going to look for the second line, which is the 2nd of Feb, which it does exist. So the marketing spend on this date was 1,162, hence we have it over here. So the first 4 columns come from table A, and then the other 2 columns, which is marketing spend and promo, come from table B, which is, not this one, which is these 2 over here. Same case with the 3rd row, the 4th row, the 5th row, the 6th row, the 7th row now, it doesn't exist in table B, so we're not going to have data, which is the 7th of Feb, as you can see. And then for any rows that exist in table B, we are just going to exclude them. So you can see here we don't have anything for the 30th of Jan 2023 because it's on the 2nd table, and on a left join we only keep all the rows from table A, so the left table. And now if we read the notes here, you can see that all rows from table A will exist in output table. So these are all the rows and they do exist. So this is it. Not all rows from table B will exist in the output table. So you can see these rows, they do not exist in the output table because they don't have a match. So we don't want them. Table A and the output table should have the same number of rows. So this is actually very important because We're going to show it later on in Python how easy it is to create duplication when you're left joining. So as a data scientist or a data analyst, you will always need to check the output table just to make sure you have the same number of rows from table A and the output table. And then if the final output table does not have the same number of rows, then it means we have duplicated data. So we need to address that as a data analyst or data scientist, because we're going to show the wrong numbers and the wrong aggregations to the business. Now we need to take this example now back into Python and test it. Right, starting from the libraries we are going to use. So this is actually where we left it in the previous tutorial. We are going to use operating system, Numpy and Pandas. So we're going to run this. Then we need to load our raw data. So we have 4 files, and just to quickly explain them, the first one is our main data. So we have the car ID, the symboling, the car name, and then information about the car. Then on the second file, we have the car prices. So car ID, car name, and then the price of the car. The third file, it has the car ID, the car name, and then information about the car body. And then the fourth file, it has exactly the same data as all the other files. And this is the file we are going to use to union the data together. Right, going back into Python now, in order to load these files, you need to type in pd.read_csv, and in the brackets, you need to specify the location of the file. So you can go where you've downloaded these files, you can right click over here, properties, you can get the location and then copy this and then paste it into these brackets. And also make sure you use double slash, not single ones. And at the end, add the .csv with the name of the file. And then we click on run. Over here, I also print the shapes. So the shape is going to return the number of rows and the number of columns. So you can see our main data, which is this file over here. It has 193 rows and 20 columns. The car prices file, it has 197 rows and 3 columns. And then the car info, it has 191 rows and 7 columns. And then we need to visualize the data. So over here, you can run the .head in order to print the first 5 rows. So if we start from the main data, this is our main data, and then if we undo and we do the car prices quickly, these are the car prices, and then the car info, if we run it quickly, we can see is the car info is actually the third file, which is the car body, but I have actually named the car body into car info, so information about the car. Right, so as we said before, now we are going to try and join which file we want to join the main raw data with the car information. So our main raw data is this file, and then the car body, which is the third file, is the second table that we want to join. And this is because we don't have these columns. So wheelbase, car length, car width, the car height, and the car weight, we do not have these columns into our main data, if you check. So we want to join these 2 tables together in order to have one file with all the information. So the first step I always do is to print the shapes. So I type in print, the number of rows for table A, as you can see, is 193. And then I also do the second thing for the car info, and the number of rows for table B is 191. So straight away we can see that we don't have exactly the same number of rows. And if you remember, as we said before, when we perform a left join, the output table is going to have exactly the same number of rows as the first table. So we expect, after we do the join, we expect to have 193 rows. The next thing I always do is try and investigate which data exists on table A and it doesn't exist on table B, and also which data exists on table B and it doesn't exist on table A. To do this now, we need to run this query down here. So we want to select everything from the main raw data where the car name isNodeIn, actually I have .isIn, but because we have this symbol over here, it means that isNodeIn, the car name coming from table B. And just to break it down quickly, so if I run this .unique, just to explain you what it does, it has all the unique car names from the car info table. And then what I'm doing here is that I'm trying to investigate if the car names, so these names do not exist in the main row data car name. We have actually explained how to do this .isIn and isNodeIn in our Pandas tutorial, which is the previous video, the step 2. So what we see from our output, if I remove this quickly, is that these rows, so these Mercedes 1, 2, 3, 4, they actually exist in table A, but don't exist in table B. So they exist in the main row data. They are actually, if we scroll down, they're actually down here, these Mercedes, but they do not exist in our table B, which is this table over here, the car body. You can see they are not here. Also, we need to do the same thing from table B to table A. So if I run this below, it's exactly the same query now, but I switch the table names, we can see that these two rows, they exist in table B, but not in table A. The next thing we need to do now is to identify the key column. So the column we are going to use to match these two together. And straight away, you can see that we have two columns that could potentially be key columns. The first one is the car name because it exists on both table A and table B, which is this one over here, car name. But also we have this car ID over here. So usually in a business scenario, these IDs are the key columns because they are unique IDs. However, we are going to try and join the data with the car name and see what we are going to get. So I'm going to copy this first example over here, so make sure we run it. So in order to join these two data frames together, we need to type in pd.merge, open brackets, table A, which is our main row data, table B, which is our second table, comma, how equals left. So in this how is where we're going to specify what type of join we are going to use. And the types are down here, left join, inner join, full join, cross join, or union. Actually, union is not a join, but we're going to show it later on. Comma, left join on, and then comma, right join on. This left join is the key column coming from our first table, which is this one. And the right on is the key column coming from our second table. And the reason we have left on and right on is because maybe the column names are different. So this gives us the opportunity to specify the key column from our first table and the key columns from our second table. I said columns because maybe it's more than one column. And if I run this join together, so first of all, let's actually visualize it. So I'm going to do dot here just to show you that it worked. If I scroll all the way to the right, we can see that we have new columns now into this final DF. This car ID Y is the car ID coming from our second table. So because they have the same name, it actually created a new column with a new name and named it car ID Y, but it's actually the same one with the car ID we had before. So you can see it over here. They're going to have the same values, but different name. And then wheelbase, car length, car width, car height, and car weight, which come from table B. Now, the next thing we need to check is the shape, because if you check the shape now, you can see we have 377 rows, which is not what we expected because table A, if you remember, up here has 193 rows. So this means, as we've explained before, that we have duplication when we use car name in order to do our join. So down here. So this means that our key column, which is the car name, must have duplications and it creates multiple joins. If we check the row data quickly, this is main data, and we go into home conditional formatting and we check for duplicated values, click OK. You can see that these are duplicated values, these two. and these two, and these two, and these two over here. These are actually different cars because they have different, let me quickly add color to them so we can visually see them. And this one, let me pin this, add the color. So these two are actually the same car maybe. Okay, so these two are, no, they have different data over here. So you can see it's probably a different version of the same car. Hence we have a different car ID, but the same name. So it's the same case with this one. If we check, it's the same. This one is actually the same car, so we might need to drop these duplicates. This one we also need to check. So if we select these two quickly, is it the same car? So this is the same. Oh, it's different. So you can see the engine size is different for this one. So for some of them, they are actually duplicates that we need to remove. And for some of them, they are actually different cars. However, as you can see, the IDs are different for these ones. So the IDs should have been the key column that we should have used in order to run the join. So instead of having car name here, I have another example down here that we actually use the car ID. So I'm going to copy this and paste it over here, run it again. So now the total number of rows is 193, which is exactly the same as table A. You can see, so the join worked correctly now with no duplicate values. And then if we also check the data frame, just to visualize it, we go here, you can see over here that we have all the columns from table B, and also for car name, we have this underscore Y because car name actually exists on both table A and table B. And because we cannot have the same column name for two columns, Python itself adds this underscore X and underscore Y just to make sure we have different column names, so we don't have the same column names. So down here, I have multiple examples of how we can run the same thing. So this one we have just shown. The second example is that instead of adding both data frames into brackets, we can actually add the first data frame, so main row data dot merge, instead of having pd dot merge. And then into brackets, we put the second table, which is the car info, and the rest is the same. The third example I have is when we want to select specific columns from our table B. So here I'm only selecting car ID, car name, and wheelbase. And if we copy this and run it at the top so we can visualize it, so I'm going to copy this, put dot head, open brackets, then run this, and then scroll all the way to the right, we can see that car name and wheelbase are the only two new columns in our final data frame. And this is because car ID we have used in order to join, and then car name and wheelbase is the only two new columns. And then the last example I have is when we have the same key on both tables. So instead of writing left on and right on, if the name of the column is the same on both tables, then all we need to do is type in on equals, and then into the square brackets, add the column name that exists on both tables. And if I copy this, I paste it at the top quickly, and then we run df4, you can see it's exactly the same data as before. And if we also want to remove this car name Y, because it's exactly the same as here, we can actually remove it from here. And this is only joining wheelbase, so you can see that's the only new column in df4. Right, I'm going to rerun this quickly, and then I'm going to continue down here. The next thing I want to do for my final df, so I have a few steps here. As we said, we investigate the shapes. So if we run this, we can see we started with the main row data as table A with 193 rows, and our df, which is our final df, which is this df over here with the car ID join, not the car name, it has 193 rows. So it means our left join worked correctly. The second thing I have down here is selecting the data that did not match. So this is basically the 4 columns that are going to have data for table A, but not any data for the columns in table B. So if I scroll all the way to the right, you can see because there was no match in table B, we have nones over here. The third step I have is if I want to replace these nones with 0. So the way to do this is to say df, then the name of the column, then dot fill na. This fill na is going to replace the none with 0. And then another way of doing it is by replacing the whole data frame, not a specific column. So if I run this final bit, I also need to pass it like this. And this is going to fill the whole data set, so all of these columns that have nones with zeros. So if I run it again, so let's do dot tail because it's at the end, we can see that we have zeros for these non-matching columns. Right, the next thing we want to do is that we also want to left join price. So if I quickly visualize this df, so dot get, we can see down here that we finish with the curve weight, but we also want to add price. So price is going to come from our second table, and this is the price of the car. In order to do this now, we need to follow the same steps. So step A is that I investigate the shapes. So if I run this quickly, you can see the shape of table A is 193. The shape of table B is 197. Then if we want to investigate all the data that exists in table A and not table B, I need to run this, so very quickly. You can see these cars exist on A, but they don't exist on car prices. So we shouldn't expect to have a car price for these cars. Then we want to investigate all the cars that have prices but they don't exist in table A. So these are the cars. For example, for these Audis and BMs, we are not going to have them in our final data frame because we are using a left join. So we are completely going to exclude this. And then we run our join. So I do df, which is our table A, dot merge, car prices, table B. How I'm going to use a left join, and I'm going to join on car ID, which is our key column. And if I run this again, you can see that the number of rows for our join, which is this final df, which is this over here, is 193. And now we have 2 new columns. And if we check them, the first new column is this car name, which we need to drop. And the second new column is this car price over here. So now we have a price for our cars. Right, moving on, we have the inner join. So if you understood the left join, then the rest of the joins are going to be easy for you to understand. Very quickly, if we go back into Excel, so we can explain the inner join. So the inner join is when we only want to match data that exists on both tables. So we don't want data that exists on table A and not in table B, but we also don't want data that exists in table B and not in table A. So the same example as before in the left join, we're going to start with the first row. The 1st of Feb 2023 is not going to find a match, hence is not going to be included in the output table, because we are using an inner join now. So they actually need to match in order to move to the output table. Same case with the 30th and the 31st. These two do not exist in table A, so they are not going to go in the output table. The only ones that are going to go in the output table are these over here, because they do have matches. So they are actually going to make it in the output table. And then these 3, they do not have matches, so they're not going to be in the output table. It's as simple as that. The output table will only have the matching rows from both tables. And the process of running this inner join is exactly the same as the left join. We start by printing the shapes, so we know the number of rows on both tables. There we go, 193 and 191. I am going to join the same data as before. so the main row data and the car information. But in this case, I'm going to use an inner join instead of a left join. So if I run this code, which is exactly the same code as this one, so let me show you quickly. This code is exactly the same from this one. The only thing I'm changing is the how. In the how I have inner join. I come back down here in the inner join. There we go, inner join. The shape now is 189 rows. So we started with 193 and 191, but we have less rows now because I'm excluding anything that is not matching. And if I want to select anything that is not matching, it's exactly the same thing as we've done before. If I run this now, we can see all the data that is not matching from table A. So we exclude this. And if I run this code, which is the same as before, this is all the data that exists on table B that doesn't exist in table A. So I'm excluding this data too. That's why I have less rows now. Right, moving on, we have the full join. And if we explain the full join, so if we go over here and the full join, so let's say that the business asks you to bring this data together. However, they don't want to miss any data. So they want to include all the data from table A, and we also want to include all the data from table B. So this is where we use a full join. A full join, as you can see from this visual, let me make this bigger. You can see that we're going to start with the first row, the 1st of Feb 2023. We're going to try to join it. We are not going to find a value to join it. However, we are still going to include it in our output. We are going to repeat the same process for every other row. So this one matches. This one doesn't match. It's still going to go in the output. And then we're going to start the same process from table B. We're going to say, is this row matching? No. However, I still want to include it. So the date is going to go here. And these two columns or values are going to go here. Same case with this row, it doesn't match, however, we still want to see it. And then the same case with the last 3 rows. These 3 rows, they do not match, however, we still want to see them at the end. So all rows from both tables are going to exist in the output table, whether they match or not. And to showcase this in Python, we are going to repeat the same processes. So step A, we visualize the shapes, is exactly the same data as before, the main row data and the car information. And in order to run a full join now, this is exactly the same query as before, the left join and the inner join. However, in the how, instead of having left or inner, we are going to have an outer join. An outer join is the full join, and we are joining on car ID, which is the same as before. If we investigate the output now, the shape is 195 rows, and this is because we have the 2 extra rows that exist in table B and not in table A. If you remember, we've run this is the 4 from table A, but these 2 rows are the rows that exist on table B and not in table A. And the reason we have 195 now is because we kept all the data from table A, 193, plus 2 extra rows from this table, table B, which are these 2 rows over here. So if we add them together, we have 195 rows, and this is our data frame. And if we want to visualize those rows, we can run the dot tail, which is this one over here. So you can see, let's do tail, I think let's do 7, so we can visualize all. If we scroll to the right, what's happening here? I think we haven't run it. Let's run it. So we click run, and then we run our tail. If we scroll to the right, we can see that these 1, 2, 3, 4, which is this 1, 2, 3, 4, they don't have data coming from table B, so they have all these nones. And then these 2 rows are the last 2 rows that have data for the second table. You can see it starts from here and the right, but they don't have any data coming from table A. That's why they have the nones. So to recap, we always use a full join when we want to keep all the data from table A and all the data coming from table B. Right, moving on, we have the cross join. So if you go to Excel to explain it over here. So a cross join is when we want to join everything with everything. That's how I explain it. So we want to take this first row and then replicate it. So literally copy it, paste it over here, and we need to paste it as many times as the number of rows from table B. So I'm going to paste it 6 times because we have 6 rows. And then I'm going to join all of these with all of these. Then I repeat the same process for the second row. I take it, I copy it, I paste it as many times as the number of rows from table B. And then I have this data over here, down here. So all rows from table A will be matched with all rows with, not will, so with all rows from table B. We do not need a key column to join on. So as you can see, we don't have a key because we are matching everything with everything. And there will be duplications. So you can see there's loads of duplication here. So these numbers are actually duplicated all the time. So be careful how you use cross joins. I have used cross joins, I think, twice in my career, but they do have their applications. And the output table, so the total number of rows will be 24. And the reason we have 24 rows is because we need to do 4 times 6. So as you have 4 from table A, 6 from table B, which gives us 24 as the final number of rows from table B. Now going back, just to show you how we do this, because we do not have a pre-existing function, or at least I don't know it, we need to create it, the function, manually. So you can copy this and paste it. So what this does is that we do a merge without the keys. So we actually use the join as before, but we drop the keys because we don't want a specific key to match them. We want to match everything with everything. Then we print the shapes of table A and table B, and then we run this cross join. Then we open brackets, we put table A, which is table 1, table B, which is table 2, and then we run it quickly. You can see now the shape is 36,863, and this is because if we do the math manually, which is this math, is 193 rows coming from table A times 191 rows coming from table B, which gives us 36,863. And if we also view the data, so if we do .get, I don't know, 10, so you can see the duplication, you can see all of this is exactly the same data, but what's changing is that we take this first car, this Alfa Romeo Giulia, and we match it with every other car from our second table. So we create all this duplication. This is why I said you need to be careful when using these cross joins, because they create a lot of duplication. Right, next we have the unions, which is the concatenation of 2 datasets. So unions are very useful because, let's say, table A is the data for today, and then tomorrow we get new row data, which we want to merge with the old row data. So it's exactly the same columns as you can see, date, day, visitors, and revenue. And we want to have an output table that concatenates or unions the 2 tables together like this. Now we are not joining like this, we're actually joining like this. So we are unioning. So table A and table B must have exactly the same number of columns. As you can see, 1, 2, 3, 4 columns, 1, 2, 3, 4 columns. And then the output table will use the column names from table A. So we are actually, if we run the union in Python, we're going to have these column names and not these column names. Even though they are different column names, we are going to only keep the index and the column names from table A. And then the maths, if we check the total rows, we have 7 rows coming from table A, these 7. And we also have 5 rows coming from table B, these 5. If we add them together, we are going to have 12 rows. And then if we jump into Python now to show this, we are going to use our df_final, which is the data frame we created in the left join that has the price. So if I scroll up, I think it's not this one, not this one. Here, df_final is this final data frame that has the price. And then we are also going to use our fourth Excel file, which is this neurodata, which is this neurodata over here. So it's exactly as I said before. Maybe we got some neurodata from the business and we want to first join the data as we've done before and then union it. So we have all the data together. So if we go back into Python now to visualize our data, which is this union. So if I run the shapes quickly, you can see we have 193 rows coming from our final df, which is this one over here that has the price, and 28 columns. And then the second table has 16 rows, which is this neurodata over here. It has 5 rows here. Why do we have 5 and this one 16? Neurodata. Oh, because it's the head, sorry. It's me being stupid. If I run the whole, so if I remove the head, we are going to have 16, which is this one over here. So I'm going to undo quickly. So we have 16 rows and 27 columns. So what this is telling us straight away is that the second table, it has 1 less column than the first table. So as we said over here, we need to make sure that we have exactly the same number of rows and also in the same order. So I'm going to go back into Python and I'm going to delete all rows that are not needed. So from the first table, if you remember when we created the joins, we created this car name underscore y and this car name underscore x, which are not needed from our final df. So here I'm going to drop them, car name underscore x, car name underscore y, and from my second table, which is table B, which is this neurodata, I'm actually going to draw the price 2 because I don't need it. I don't have a price 2 column in the first table. If you only want to investigate the column names, you can actually do this dot columns and run this. This is going to give us all the columns from table A. You can repeat the same thing for table B, which is the new row data, but because I know from before that I created these 2 new columns that I need to drop, and I also know that price 2 does not exist in table A, I'm just going to drop them quickly, then re-investigate our 2 data frames. So as you can see, car ID, if we start from the beginning, car ID symboling fuel type. So I'm missing the car name, and this is because car name is over here. So actually I have to move car name from the end to the third column because we need to keep the same index. So we need to keep the same order over, where is it? Over here when we are unioning. So a way to reshift the columns is by running this code over here. So what this is doing is selecting the df_final. So df_final, so I'm going to change this df_final. So I copy it and paste it over here. And then instead of specifying the columns manually like this, so the order of the columns, I can actually select the columns coming from the second table. So if I do this quickly, if I actually run it, so you see this is going to return the order of the columns from the second data frame. But instead of copying all this and pasting it in here, so this is going to give me the right order, I can actually type in the second table dot columns and run it, and this is going to reorder the column names of this data frame based on the order in this data frame. So I'm quickly going to remove these 2. Then we have run this, and then in order to run this concatenation is by saying pd.concat table A, table B, ignore the index, and then the number of columns of both tables you can see is 209, and this is because we are adding the number of rows from table A with the number of rows from table B. Actually, this is, let's do C over here, and this is neuro data, so it's BA. If we run it again, what did I do? Let me do undo, run. Table C, like this, is 209. And then if we investigate it quickly, if we do this, dot head, we have successfully union. Let's do tail actually, because tail is going to have the last 5 rows. And these last 5 rows, they come from our neuro data, which is these volvos. So let's test them. These volvos, if we go on the left, you can see is these volvos over here. So we have successfully union our data. Right, this is it for this video. I hope you've understood how we use joins and unions in order to bring data together using Python. Unions and joins are very, very important because as a data analyst or a data scientist, you will be joining and bringing multiple data sources together in order to run your analysis and your machine learning models. Right, so I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, then please click the like button, subscribe to my channel, and enable notifications for my future videos. In the next videos, we are going to cover the MatPlotLib and then the Seaborn library. So how we run these visualizations using Python. So we are actually going to use the same data set, the one we've just used for the joins, in order to show how we create all these visualizations. Thank you very much for watching this video, and I'm going to see you in the next video.